Today's section of 12.4, we're actually going to be talking about the segment lengths, no longer talking about the angles. To start us off, we have our guest speaker, our very first, well, not first one, she's the teacher here, Mrs. Reed David.
Hello everyone. So the first formula that you will learn today is going to be about chord inside a circle. So if you can see from your screen right here, is A times B equal to C times D. So A will be right here at this part. And the second part here will be a B. Then that will be a C and D. Just remember A times B equals C times D. A, B have to be from the same chord, while C, D has to be from the same chord. Let's do some example. For the first example that we have, first just label your A, B, C, and D, and write down the formula. A times B equals C times D. So now just plug in your number. So you have X times 5 equals to 6 times 10. So you will have 5X equals to 60. So X equals to 12. Follow the same procedures and you will find number 2. You should get X is equals to 4. Now take a minute to look at example number 3. It looks complicated, but just go ahead and follow the same formula. Okay, so what we're going to do is remember do A times B equals C times D. So that's A, B, C, and D. So plug it in. 6 times parentheses X plus 4, don't forget your parentheses, equals to X times 12. Use your distributive property. You have 6X plus 24 equals to 12X. You should be able to solve for your algebra. If you get it right, your answer is going to be X equals 12.
Next section we're going to talk about is secant. The formula for this one, we're going to do W times W plus X, which is the outside part of your secant times the whole thing of your secant. And then that's going to be equal to the other secant, the outside part Y, times the sum, the whole thing, Y plus Z. I like to kind of put this to a little bit of a song. Whole thing times outside part equals whole thing times outside part. And seriously, when I'm writing my equations, I'm saying that out, drawn out, whole thing. So I'm adding plus times outside part. Let me show you an example. For the first one, I'm going to focus on this top secant right here. The whole thing would be 6 plus 4 times the outside part, which is 6. And that's going to equal for me the whole thing of this, which remember is adding 5 plus X times the outside part, which is just 5. Okay? So now I'm going to go ahead and combine my like terms. I can actually do the math here. 6 plus 4 is 10. 10 times 6 gives me 60. And then we're going to distribute on the other side. So we get 25 plus 25 plus 5x. All right. So if you guys solve this out, you should get for your answer that x equals 7. All right. Now the second one looks a little bit different, but we're going to do the same thing. Keep in mind doing the whole thing times the outside part, whole thing times the outside part. Let me go ahead and erase what we've got going on over here so we have room to work it out. All right, so the whole thing on this top one, notice they say up here it's equal to x. All right, so the whole thing is x times the outside part, which is 5. And that's going to equal, again, the whole thing here, which is 6 plus 4 times the outside part, which is 6. So we get 5x is equal to, again, this is 10 times 6, or 60. And you get x equals 12. All right, see if you can set up the next one. It's a little bit more algebra, but you're going to still do the same thing. Whole thing times outside part equals whole thing times outside part. All right, so hopefully you've already paused, you've tried it on your own. This is what you should have come up with. 15 is my outside part times the whole thing, 3x plus 15, and that's going to equal my outside part again, 20 times the whole thing, 20 plus x. If this is how you started or it looks similar to this, you should be on the right track. And I got that x equals 7.
All right, saving the best for last. Tangent secant, that's what TS stands for. And the formula for tangent secant is very similar because you have a secant line here. So if you notice this secant line, we're just changing the variables. The outside s times the whole thing, s plus t. What is different now is this r squared, which is now our tangent line. Okay? So remember, tangent, you got to square that. And then you're just going to do the secant part, which we just learned from Ms. Hurst. Okay, so let's go ahead and do 2 final problems for today. All right, first one. Identify where your tangent line is. Tangent line is here, so this is my r, s, and t. So we have r squared equals s times s plus t. So 31 squared equals 20 times 20 plus x. Okay, so r squared is 961. And then you've got to distribute the 20 to both. So that equals 400 plus 20x. Subtract out the 400, you get 561 equals 20x. And don't get nervous because you start seeing right here that you're going to get a decimal. And that's okay because decimals are numbers too. So 28.05 will be part of that secant line. See if you can solve the last one on your own, solving for x, which is actually our tangent line. All right, so let's take a look at what I did, and hopefully it matches what you did. Our x squared, so remember to get rid of an x squared, you've got to square root it. So don't forget the square root on the last part. All right, so keep on trucking with those formulas.